In order to solve by factoring, you do need to have your equation equal to 0 and the other side of the equation in standard form. So this equation, we don't have 0 on one side. So I'm going to subtract a 26x squared on both sides. That'll give me 0 over here on the right side. And then on the left, if I arrange these terms in standard form, we will be ready to go through and try to factor. When you go through and you factor the left side of this, there's nothing in common, and with three terms we should try the add multiply method. I do see that the powers here are a little bit different, but it's still a quadratic pattern. We have an x to the fourth here for the first term, x squared for the middle term, and then our constant. If I look at the powers of x for those first two terms, the first one is twice as big as the second. So we should be able to go through and do some factoring on this using our add multiply method. Looking for two numbers that add to be a negative 26, our middle term's coefficient here, and then multiplies to be the invisible 1 in front of the lead term times the constant, and 1 times 25 is 25. There are two numbers that add to be negative 26 and multiply to be 25. Those two numbers are negative 1 and negative 25. Because this is a quadratic pattern with a 1 in front of our x to the fourth term, I will be able to factor this using the shortcut, but I do need to recognize that my two sets of parentheses that we're going to get when we factor using our numbers that we found with the shortcut, these sets of parentheses need to start with an x squared. It is the middle term variable and exponent. Usually we just do an x because the middle term is x. This one's an x squared, so we do need to start each of those parentheses with an x squared. And then using our numbers, one of the sets of parentheses would be an x squared minus 1, and the other an x squared minus 25. I've done some factoring already, but I can factor each of these sets of parentheses. Again, both of these are a difference of squares pattern. X squared is a perfect square, and so is 1. And we have subtraction in between, so they would factor as an x plus 1 times an x minus 1. The second set of parentheses, x squared, is a perfect square. It's x times x, and 25 is 5 times 5. So an x plus 5 times an x minus 5 is what we would get if we use the difference of squares pattern on that second set of parentheses. I now have four things being multiplied together that are equal to 0. I can set each one of these equal to 0 and solve for our four solutions. So there are four solutions. Those four solutions are negative 1, 1, negative 5, and positive 5. You can leave your answer separated by commas like that, or you could even put x equals in front of each one for your final answer.